Hello everyone. In this lesson, we will talk about multiplying and dividing exponents with common bases. I would like everyone to recall the definition of power, or the also called definition of exponent. So a power is a term consists of a base and an exponent. The whole thing here is called a power. Okay, so or sometimes they just call it exponent. But the correct term for that would be a power, and it consists of a base and the exponent. Okay, so the exponent will tell me how many times I multiply the base by itself. So in this case, it's the n time. So then I have to make sure that I have to multiply the base n times. So this is the definition of the exponent, and n is the exponent, which indicates that a is the base. We need to multiply by itself n times. Okay, so if you have a base and a power, an exponent, or a raised to an exponent, or a raised to a power of, then the whole thing is called the exponent or a power. But most of the time, they actually use the word exponent, so it's easier to remember. Okay, so there's a rule to perform the multiplication and division of exponent with common basis. So I'm talking about the same basis in this case. Okay, so we will base on the definition of the exponent, so to provide whether or not we can apply the formulas as addition and subtracting the exponent. Okay, so let's start with this example right here. So for example, I am having a raised to the exponent 3 multiplied by a to the exponent 4. Okay, so in this case, if I apply the definition of exponent, okay, the exponent telling me that the exponent will tell me how many times I multiply the base by itself. So now you see that a to the exponent 3, so the exponent 3 will tell me that I will have to multiply a by itself 3 times. So see, I labeled it in red. So here I will have a times a times a, representing a to the exponent 3. And then I multiply with the a to the exponent 4. Notice that I have the same basis to work with. Okay, so the exponent 4 will tell me that I multiply a again by itself 4 times. So 1, 2, 3, 4. Okay, so let's count all the terms together. Excuse me. Then I have a times a. So it's 1, 2, 3, 4, 5, 6, 7. So altogether, I have 7 of this a. So I can write it at a to the exponent 7. So it is more like I'm proving the formulas for you. If you are multiply the two exponents with the same base, then you will have to leave the base the way it is, but you will add the two exponents. You see? Or we can say that the rule for multiplication of two powers with the same base is we are going to add the two exponents. So if we can put exponent as well, so it's more like a common term that I'm using here. Okay, so each time that you multiply the two powers with the same base, you don't want to use the definition like this and expand the exponent, count how many bases that you have, and then raise it to the power according to the definition. So that's why the formula is created to provide you with a shortcut. So in this case, what I have is I can say that a to the exponent 3 multiply a to the exponent 4. I apply these formulas here because I have the same basis to work with. Therefore, I add the two exponents. Don't forget, these formulas only apply for the powers with the same base. All right. So I did take 3 plus 4. I got 7. Excuse me. Just allow me to have a sip of water. Okay, thank you. And now, just continue on to the next example. this example, I would like to show you when we divide the two powers, okay, divide one into the other. And I will use the exponent definition to work with as well. So a to the exponent 5 divided by a to the exponent 3. If I use the definition of exponent, I will expand this to have 5 bases that a multiply together. So you see 1, 2, 3, 4, 5. So I can expand this base and write it as the multiplication of 8 5 times. I do the same for the denominators. So because a raised to exponent 3, I will write a times a times a. So a repeats, multiply itself 3 times. So now you can apply the concept of fraction. You can cancel one term that is the same. A cancel with this a cancel with this a cancel with this a. So what do I have left? I have a times a left. Apply the definition. Because I multiply the base by itself 2 times, so I can write it as the same base but raised to exponent 2. Okay, so you note that 5 subtract 3 will give me 2. Therefore, the rule for division of 2 exponents with the same base is you just take the top exponent, the exponent for the numerator, subtract the exponent of the denominator. Okay, it's always like that. The exponent of the power as a numerator, subtract the exponent of the power as a denominator. So in this case, the formulas apply as a raised to exponent m divided by a raised to exponent n. What you do is you have to take m subtract n, leave the base the same, and one condition for this is a cannot be equal to 0 in this case, because if you have 0 as the denominator, it's an undefined condition. So therefore, you do not need to expand this. You do not need to apply the definition, because I am using this to prove to everyone the formulas here. So what you have to do in this case is just, if you see that you have the same basis to work with, then you just subtract the 2 exponents. All right, so 5 minus 3 could be a to the exponent 2. Okay, what about raising a power to an exponent? Okay, raising a power to the exponent, the rule represented as we multiply the 2 bases, the 2 exponents together. Okay, so if you have a to the exponent n, all of it raised to exponent n, so what you do in this case, you multiply the 2 exponents. Okay, so in this case, if I apply the definition, it will be the same concept, but I will skip that. All right, so what I have in this case is you are going to have x raised to exponent 4, all of it raised to exponent 3. Therefore, you multiply the 2 exponents, will give you x to the exponent 12. In this case, you raise a power to an exponent. All right. Okay, so let's work with a few examples. So example number 4, asking me to perform the following operations. And then I have like 2 times x to the exponent 5 multiplied by 3 times x to the exponent 3, the whole thing divided by x to the exponent 4. So in this example, all the bases are the same. So that means we add the 2 exponents in the numerator and subtract the exponent in the denominators. Okay, so let's write this down. You see, so in this like a workbook, and what I do is I leave some space to work with. All right, so first of all, what about the number in front of this? So I want to remind everyone that the 2 numbers in front of this is called the coefficient. Okay, so 2 and 3 are the coefficients of the term x, 2 times x to the exponent 5. This is called a term. 2 is the coefficient for this term. 3 times x to the exponent 3 is a term. And 3 is called the coefficient of this particular term. So what you do is you multiply 2 by 3 first. So we'll give you 6. Okay. So 2 multiplied by 3. Because right here is a multiplication. You just multiply the two coefficients. 2 times 3 gives you 6. And about the exponent, what you do is, because you are multiplying this 2 powers with the same base, okay, 2 powers, same base, so you just write it as 1 base of x and 5 plus 3, okay, according to the formulas above. If I multiply the 2 power, I add the 2 exponents. So that's the formula that I'm using. And the next step is, because x is also the same base, so I can go ahead and subtract the 4, right? So because I apply this formula here, I apply this. If I have the same base and the 2 power divide into one another, take the top exponent here for the numerator, subtract the 1 as a denominator. So then after I add this 2, I subtract the 4. So all you do is just perform the operation for the exponent. So 5 plus 3 is 8. 8 subtract 4 is equal to 4. So in this case, I will have 6x raised to the exponent 4 as the final answer. Okay, so I want to remind everyone, because you need to remember this term in order to answer question on the assignment. So 6 is called the coefficient, okay? Okay, or we can say a numerical coefficient. And this is the base, and this is the exponent, okay? So remember the terminology in this case. So this whole thing here is called a term. Okay, this whole thing here is called a term. A term consists of a coefficient, a variable. Okay, so in this case the variable is x, but x raised to the exponent 4. So this whole thing here is called a power, and the power consists of a base, and this is the exponent. So don't forget this important terminology. So if I ask you for what is the term, then you can say this is the entire result, is considered a term. But if I ask you for the coefficient, you know the coefficient is the number 6. If I ask you for the final result for the exponent, then it is 4. Okay, the base in this case remain as the x. All right, so let's see what I have left. Yeah, I have plenty of time, because don't forget each video is 30 minutes. All right, or I cannot go over 30 minutes. So that's okay. Now we move on to example number 5. And I would like you to note this, okay? So in example number 4, you see that all the bases are the same, x, x, and x. In this case, I actually changed the bases, is x, then I have y, is x, then I have y, and I have these 2 terms multiplied with each other and divided by this. So what I will do step by step. All right, I will do step by step. So the first thing I will do is I will work with the numerator first, and after that I will work with the denominators. All right, or you can just do them all at once. It's entirely up to you. Okay, so first of all, I want to remind everyone one term. So if it's just y, then it's actually y to the exponent 1. Okay, the 1 is the invisible one in this case. It's not 0. 0 is totally different. Okay, anything raised to the exponent 1 is itself again. So in this case, I have y. I don't write the 1 here because we have to understand that this is y raised to the exponent 1. Okay, so again, you are going to multiply the 2 coefficients together because it's a multiplication. So then I will have 2 times negative 2 will give me a negative 4. Okay, so I would like to say that I'm working with the numerator first, and then I will take care of the denominator later. Okay, so after I complete the operation as the numerator, I will perform the operation by dividing this into the result. Okay, so I have a note here for everyone. All the bases are different. We add and subtract the exponent with the same basis only. Okay, so x goes with x, y goes with y. So I will write x. So that means I will take a look at the -6 and the x to the exponent 8 here. They have the same base, right? So now I will add these two exponents. Therefore, I will have -6 plus 8. All right. Okay, so now continue with the next power. Y to the exponent 2 and y to the exponent 5, because they are the same base. So I will write y, just one base, and I will take 2 plus 5. All right. Okay, so -4. Here is, so let me give myself some more space. Okay, so I will have it as -4 x raised to the exponent -6 plus 8 will give me 2. Okay, 2 plus 5 will give me 7. Okay, so here it is. Now you can go ahead and start dividing with this. I mean y to the exponent 1. Okay, excuse me. And what I have is I will write -4 now, and x, and what I have is 2 subtract -5. Okay, make sure you write -5 in the bracket, because negative and negative will make it a positive, so it's very important in this case. And then I will write y to the exponent 7, and I subtract the 1. Okay, then what I have, if I should have -4 x raised to the exponent 7, because 2 subtract -5 will give me 7, and 7 minus 1 will give me 6. Okay, so this is the final result. However, I would like everyone to note that I can do this question in just one step. Okay, so I can do all of this in just one step. All right, okay, so let's rewrite it here and show everyone that it can just perform in just one step. All right, so let's just write this again. 2x to the -6 y squared, and I multiply that with -2x to the 8 y to the exponent 5, the whole thing divided by x to the exponent 5 and y. Okay, so now what you do is, you know that -4 is the 2 times -2 already. Okay, and I will write x, right? X. Now, -6 plus 8, and subtract the -5 right away. Okay, and then y is 2 plus 5, and I subtract 1. All right. Okay, so you can do it all in one step. Make sure that you subtract the 1 at the bottom, but you add when they multiply. Okay, subtract when you divide, add when you multiply. So now I have -4. So again, you perform this operation up here. You see that -6 plus 8 is 2 plus 5 is 7, right? And what you have right here is you can perform this operation. And then what you have is 6. So exact same answer as I've got. You can do it in just one step. All right, so let's move on to the next example. Okay, so what I have here is, if you have any questions for me, you can send me an email if you need to. Okay, so everything should be very good here. All right, okay, so now I am going to work with example number 6. Okay, in this example, I would like you to note that I throw in the exponent right here. All right, okay, here is the exponent, and you have two different bases inside this bracket. And before we perform this operation, I would like to show you that I can apply another formulas. Okay, so if I have A, okay, times B are the two different bases, and I raise this to the exponent n. Okay, so I have no other choices. A times B raised to exponent n, but A is different, B is different. So what you do is you can break this into A raised to exponent n and then B raised to exponent n. Okay, don't forget this is actually quite important. All right, okay, so let me correct this B. All right, so what I will do is I apply it immediately for my denominators. Okay, so for this denominators, what I have is I will apply this formula to this, okay? And I raise this to the exponent 2. That means I am going to bring each of this to the exponent 2. I will have negative 3, I raise to the exponent 2. I have x to the negative 5, I raise to the exponent 2. And then I have y, and in here is the 1, right? And I raise to the exponent 2. Okay, another formulas I need to apply is this one that I have shown everyone in the lesson. So now we are going to apply this. You need to multiply the two exponents if you raise a power to an exponent. So I will write it here just to remind everyone. Okay, so you multiply the exponent in this case. So what I have is I will take negative 3 and I square that. Okay, so don't forget it's a negative in the bracket, raised to the exponent 2. So you need to raise this negative to the exponent 2 as well. In the case that you take minus 3 times minus 3, so that will give you a positive 9. So I will write here a positive 9, just to be clear, okay? And then I will have x raised to the exponent of negative 5 times 2. It will give me the negative 10. And then here I have 1 times 2 will give me 2. Okay, so that's taking care of the denominators. So now what I will do is I will rewrite the question as 5 x to the negative 3 y to the 5, and then I have 6x to the negative 2 y to the negative 4, the whole thing divided by 9, x to the negative 10 y squared. Okay, so what I'm going to do now is just like similar to the previous example. So what you do is you multiply the coefficients. Okay, do it in just one step like this. You multiply the coefficient, you pick the power with the same base, and then you perform the operation with its exponent. So what I will do now is I will do this. I will write it as 5 times 6 is 30. Okay, so now we are going to pick the one with the same base. So this one here, pick that with that, and that with that, right? So that means I just write x. Okay, so this is negative 3, adding that with negative 2, subtract that with negative 10. So don't forget to put the negative in the bracket. So my next one will be I'm going to use a different color. So this one. So the next one will be the y, right? So y to the 5, y to the 4, the negative 4 I mean, and y to the 2. So I will write y to the 5, adding that with negative 4, and then I subtract that with positive 2. So all I have to do is just write it as the 2. So what is my final answer? Okay, so now you have negative 3 plus negative 2 is negative 5. And then you subtract that with a negative 10. The answer should be positive 5. So in this case, I should have x raised to the positive 5. So if you're not sure, you can use the calculator for this. Okay, so negative 3, subtract 2, add 10. So that will be positive 5. And now you take 5, subtract 4, which is 1. And then 1 subtract 2, you should have a positive 1. Okay, so will be y to the negative 1. I'm sorry, so it will be y to the negative 1. And don't forget it's the 9. So I should done this. I should do this. This should be equal to this whole thing divided by 9. So I will rewrite that in a minute. So this should be divided by 9, right? And then it's equal to 30 over 9. And multiply this with what answer that we have is x raised to the exponent 5, y to the negative 1. But the 30 over 9, you need to simplify it, okay? So you can simplify this by divide this by 3. And you also divide this by 3. So your final result should be 10 x to the 5, y negative 1, the whole thing divided by 3 as the final answer. Okay, all right. Okay, so I just want to correct here for a second. Just make sure that the division is there, and then y raised to that exponent. Okay, so I have a few minutes left, and I want to go over this question because I think it's a bit complicated. Okay, so you can analyze the question by take a look at this. Okay, so you can only add or subtract the exponent of the same base. But in this case, you have an exponent down here. So you have to perform the operation of exponent first. So that means you apply these formulas. And at the same time, you also have to apply these formulas. Okay, so negative 3 raised to the exponent 2. This term raised to the exponent 5. Also have to raise to the 2. Y to the exponent 1 by itself here, right? And raise to the exponent 2. After I perform this operation, I got positive 9 x raised to the negative 10 y squared. And then I put them all together like this. 5 times 6 is 30 divided by 9 will give me like a decimal, but I have to leave it as a fraction. And then I pick x as the common base, right? Then I take negative 3, add this negative 2 because I multiply here. And then I subtract the negative 10 is because I divided by, okay? And again, nothing in between here means I multiply, okay? Now I pick the y with its exponent 5, adding negative 4, subtract the 2, okay? The 9 remain at the bottom, okay? The denominator. So in this case, I will have 30 over 9. This will give you positive 5. This will give me negative 1. 5 subtract 4 will give me 1. 1 subtract 2 will give me negative 1. Simplify this as the lowest term. So divide the top and the bottom by the same term 3. So I have 10 over 3. So leave it as a fraction. Okay, so don't put a decimal here. And then my final answer will be x to the 5, y to the negative 1 multiplied by 10 divided by 3. All right. Thank you, everyone. Don't forget to work on the exercise. All right. Thank you.